We're going to talk about DataMite channels now. We didn't touch too much on it during any of the other previous movies, but we're going to talk about some of the more advanced features for DataMite channels. We did talk about how if you got an absorber dyno, you've got to pick out a channel and call it dyno torque here, and you got to fill in these numbers by either reading them or whatever. We've talked about that. We've also talked about how if you got one of these set up for dyno torque, and I'm just going to do it real quick here. Uh, Basically, it's saying 0 foot-pounds is 0 volts and 100 foot-pounds is 3 volts. Obviously, you do have to do a lot better calibration than what I did there. Another thing, as we talked about, is the wide open throttle switch for marking the beginning and end of a test. You could have a recording switch. Instead of marking the beginning and end of a test, a recording switch would actually tell, instead of pressing the F1 key and the F2 key to start the recording, you'd use a recording switch to do that. And I'm going to turn it back to this. Another thing you may want, type in switch for the name. Turn it on here. You got to put a yes here for it to have any effect. Another thing that you might want to do is put in a pressure sensor. And we've got a lot of standard range pressure sensors already built in. So if you got a 500 psi pressure sensor, if you just click on that and type in a name of, well, let's not go 500. Let's go 250, and let's call that oil pressure. Now you're going to have a 250 psi oil pressure sensor in there. Something else you may want to do is maybe you have an external thermocouple amp. When we can't fit all, like in the DataMite III, there's only 4 thermocouple channels we can put in. If you need more than that, you're going to have to use an external amp. Or in the mini DataMite USB, you're obviously going to have to use an external amp because there is no internal channels. And these standard thermocouples that are called exhaust, they are kind of treated special. And if it's really not an exhaust thermocouple, you shouldn't be using these because they're treated a little different. You should just call it a standard thermocouple if you got some miscellaneous temperature. And you could call it exhaust number 4, but it's not going to be graphed or shown in the current readings on that. The gauge is on the right side, and there's some special graphs that we do on just exhaust thermocouple. So if it's not a true exhaust thermocouple, you may want to call it a miscellaneous thermocouple and put whatever name in there that you want. Now, if you pick a thermocouple, you got a choice here. Is it an internal channel or is it one of these external amps? Now, the Corsa single we don't do anymore. This is also something that's been obsolete, but it's still needed in the software for the people who got the older systems. The dual compact is what most people on these USB systems are going to be using now. It's a 2-channel. It's basically a black cube, and that's what's used. That's what our current product line has. And then we have the quad, the 4-channel thermocouple amp like this. Get 4 channels in there. So if you do pick a thermocouple, you got to tell it what kind of amplifier are you using, and then you can give it some name. Maybe it's just something like that. And again, you got to turn it on. Another channel that you could want is one of our air-fuel systems, either the old single or dual channel without the gauge, or the new one with the gauge, which is actually cheaper. This single one with the gauge, and it's got its built-in calibration. And I don't know if you've noticed here, I could type in a name here, or you can also type in a name by clicking here on the grid. Clicking on OK. Whatever name you use here is completely up to you. The program uses this information to know what it really is, that it's an air-fuel gauge and what the calibration is. This is a name that you want to show up on your reports and graphs that might mean more to you than some name that we would come up with ourselves. Now, you can also have custom sensors. If you go down here, custom, user supply specs, what this means, it is a linear sensor. And a linear sensor means it's a straight line. For example, let's say you got a pressure sensor where every increase in 1 volt is 100 psi. So 0 volts is 0 psi, 1 volt is 100 psi, 2 volts is 200 psi, and like that. Those are pretty simple. And if you had something like that, you could just type in 0 psi is 0 volts, and 200 psi is 2 volts. And then you could select over here pressure. And you have basically, now you could have typed in 0 and 1 volt and 0 100 psi. It's the exact same thing. But you could do something like that. Or if you got what's called a nonlinear sensor, where maybe 0 is 0 psi, but 1 volt is 100, 100 psi, but maybe 2 volts is 400 psi, and 3 volts, oops, not 30 volts, 3 volts is 1200 psi. It might be something like that. And you can type that in and call that some other type of pressure sensor. Or let's say you put something in here where you say 2.5 volts is 900 psi. And you can see as it's graphed here, that's a little screwy, but you can resort the rows. Or you can type in 3, click over here and have it read the DataMite. Or you can insert a row above this. If you want to put in some other numbers here, you can delete a row. So anyway, there's a lot of little features down here with these buttons, so you can type in some kind of table of a nonlinear response curve. And if you click on Keep Specs, it'll load this calibration in. You can see it's a fairly complicated calibration, but that's a very valid calibration. Your RPM channels. RPMs don't require much calibration other than knowing how many pulses per revolution you're expecting. This dyno wheel happens to have 2 magnets on it. If you got a calibration for RPM that seems to be off, it's not going to be off a little bit. It's not going to be off, let's say 5%, where you would say, I think it's supposed to be reading 2,800 RPM, but it's reading 3,000. With the RPMs, they're off a lot, meaning I think it's supposed to be reading 3,000 RPM, but it's reading 1,500, half, or it's reading 6,000, double. And if you do get something like that, it's probably because you got the number of magnets wrong. Now, we let you put in a lot of different magnets, but I don't recommend doing it. I strongly recommend you don't do it. For certain applications, it might be important, but 99.9% of the time, you're going to want to put in typically 1 magnet. If you put in 2 magnets, you've got to make sure they're very evenly spaced or you're not going to get good data. So I'm going to cancel out of here. And for the engine RPM, with the DataMite 3, we have an option here. First off, you're going to say 1-cylinder 2-stroke, if it is 1-cylinder 2-stroke, or maybe it's a V8, it's an 8-cylinder 4-stroke. And for ignition, how many pulses do you want to use? Typically, you say, well, why not use all the pulses? Well, the reason you may not is because they're only separated by 90 degrees in this situation. And you can have a little bit of variation in the spacing of the ignition pulses that can make the RPM reading, because it's getting such a short window to look at, the RPM can be jumping around a lot. And you say, well, don't use every pulse, use every 4th pulse. And this can definitely clean up a noisy engine RPM signal, because it's using pretty much the same pulse each time to base things on. It's not using cylinder 7 and cylinder 3. It's using cylinder 7 and whatever is 360 degrees off from cylinder 7. Or on a 2-stroke, it'll be using the same exact pulse for the same cylinder each time. So this can really help clean up engine RPM, only available on the DataMite 3 USB. Some other things here, the DataMite USB, some options here. Once in a while, you lose the thermocouple calibrations. The box might lose them, and so you might have to reinstall them like this. Click there. Don't do this if you don't have to, because I shouldn't say that. It's not a big deal. But it says before you do this, make sure you've been communicating. And all you do here is if you click on read info, you're going to be getting, here's the firmware version there. RPM config means only something to us. And here are your calibrations, which again will not mean a lot to you, but does mean something to us at Performance Trends. You can also send the default cals, and the calibrations have been loaded. You want to save the calibrations also. If you click here, it says basically after you have stored the cals, power down the DataMite, and that's how you save them. So I've now done that. Another thing that you might want to do is you may want to use a fuel flow sensor. If you use a fuel flow sensor, you'll get a calibration number from us of a multiplier, and you could call it fuel. Fuel flow. And if you said fuel flow, what's going to be important now, we're going to save the changes. Yes. Over in test conditions, fuel spec gravity. If you don't fill out the fuel spec gravity, one will be assumed for the fuel you're using. To be more precise, you're going to want to fill this out like 0.74. And then when you fuel, just as note, that's just enter any description of the fuel you want. But you can see here, if you click on this in the help description, this is the spec gravity that's going to be used for your fuel meter. In preferences with fuel flow also, is we got a special preference here for fuel for brake spec fuel consumption. And the default, and this is only available in the Pro version, is use the first fuel channel you find. And fuel flows generally go into RPM channels, frequency channels, because they put out a pulse train. The first fuel flow channel it finds, if you've specified 2, it's going to use that to figure out the fuel flow. If you've specified 2 fuel flow channels, it gives you the option, do you want to add the first and second channels? That would be like you have half the fuel going through one fuel flow meter and half through another. And then you add the 2 together and get the total fuel flow. Or this option here where you subtract the second channel from the first. This would be the case where you have one fuel flow channel or sensor measuring the data, the fuel flow to the engine, and the other one measuring the return fuel from the engine. You take the difference, and that's the fuel that the engine has used. So let's say we want to do that, and you got to click on OK for that to happen, and then you go up here, and maybe you'd have the second fuel flow channel turned on here. Something like that. But that gives you some idea of how to set up the various channels in your DataMite. The sampling rate here, for the DataMite 3 and the Mini, set it at 50. Just set it at 50. There's no real reason to go less, and it doesn't always work well at 100. It depends on computer speed and other things. So 50 is the one that I would suggest for all cases for the DataMite 3 and the DataMite Mini USBs.